Look up at the night sky. Those tiny points of light, they're not small at all. In fact, some of them are so incomprehensibly massive that if you replaced our sun with one of them, it would swallow everything out to Saturn. Today, we're going on a journey through the cosmos to understand the true scale of stars. And trust me, your brain is about to break. Let's dive in. Before we leap into the cosmic deep end, let's establish our baseline. Earth. Our home planet has a diameter of about 12,700 kilometers. It feels massive to us, right? You could drive around the equator for about 500 hours straight and still not complete the loop. Now, Jupiter, the giant of our solar system, is 11 times wider than Earth. You could fit 1,300 Earths inside Jupiter. It's mind-boggling. But here's the thing, Jupiter is absolutely tiny compared to what's coming. Our sun, it's 109 times wider than Earth. You could line up 109 Earths across the sun's diameter. In terms of volume, you could fit 1.3 million Earths inside the sun. The sun is so massive that it contains 99.86% of all the mass in our entire solar system. But here's where things get wild. In the grand cosmic scale, our sun is actually pretty average. It's classified as a yellow dwarf star, and we're about to see just how humbling that classification really is. Let's climb the stellar ladder, shall we? First up, Sirius, the brightest star in our night sky. It's about 1.7 times larger than our sun. Not too dramatic yet. Pollux, one of the twins in Gemini, it's about 9 times larger than the sun. Now we're getting somewhere. Arcturus, that beautiful orange giant visible in the spring sky, is roughly 26 times larger than our sun. If you replaced the sun with Arcturus, Mercury, Venus, and even Earth would be orbiting inside the star itself. Rigel, the blue supergiant that marks Orion's foot, is about 78 times larger than the sun. The heat from this monster is so intense that it glows blue-white. But then we have Aldebaran, the eye of Taurus the bull. This red giant is roughly 44 times wider than our sun. If you put Aldebaran where the sun is, it would extend past Mercury's orbit. And we're just getting started. Welcome to the realm of the supergiants. These are stars that make our sun look like a marble next to a beach ball. Antares, the heart of Scorpius, is approximately 700 times larger than our sun. If Antares replaced our sun, its surface would reach beyond the orbit of Mars. Mars would literally be inside the star. Betelgeuse, the famous red supergiant marking Orion's shoulder, varies in size but averages around 900 times the diameter of our sun. This star is so enormous that if you could hollow it out, you could fit nearly 1.4 billion suns inside Betelgeuse. We're not done yet, not even close. Scuti, one of the largest known stars in the universe, is approximately 1,700 times the diameter of our sun. If this star replaced our sun, its outer edge would reach somewhere between Jupiter and Saturn's orbits. The volume? You could fit about 5 billion suns inside Scuti. And then there's Stephenson 218, with estimates putting it at around 2,150 times the diameter of our sun. This might be the largest star we've ever discovered. If you placed this absolute unit in the center of our solar system, its surface would extend nearly to Saturn's orbit. To put this in perspective, if the sun were the size of a tennis ball, Stephenson 218 would be about the size of a 2-story building. Light, which can circle the Earth 7.5 times in a single second, would take nearly 9 hours to travel from one side of Stephenson 218 to the other. Meanwhile, it takes light just 4.6 seconds to cross our sun. Let's break this down in ways that might actually make sense to our human brains. If Earth were the size of a grain of sand, the sun would be about the size of a golf ball. Now, Stephenson 218, it would be about 12 meters across, roughly the size of a large house. Here's another one. Imagine you could drive a car at highway speed, 100 kilometers per hour. To drive across Earth's diameter would take you about 5 days. To drive across the Sun would take you over 6 years. To drive across Stevenson 218 would take over 12,000 years. The volume differences are even staggering. You could fit 1.3 million Earths inside the Sun. You could fit 1.3 million suns inside UY Scuti. That means you could fit approximately 1.7 trillion Earths inside UY Scuti. And yet, despite being unfathomably massive, these supergiant and hypergiant stars are incredibly diffuse. The density at the outer edges is lower than the vacuum we can create in laboratories here on Earth. You could, theoretically, fly a spaceship through the outer layers without even noticing. Here's the beautiful paradox of these cosmic giants. The biggest stars have the shortest lives. Our Sun will live for about 10 billion years total. It's currently about 4.6 billion years old, so it's got another 5 billion or so to go. But Stevenson 218, stars this massive burn through their fuel incredibly quickly. They might only live for a few million years, which in cosmic terms is the blink of an eye. They live fast, die young, and when they go out in spectacular fashion, exploding as supernovae and sometimes collapsing into black holes. And here's the really mind-blowing part. Every element in your body heavier than hydrogen was forged inside a star. The iron in your blood, the calcium in your bones, the carbon that forms the basis of all life, it all came from stars that exploded billions of years ago. We are quite literally made of star stuff. So the next time you look up at the night sky and see those tiny pinpricks of light, remember, you're not just looking at distant suns. You're looking at objects so massive that they defy human comprehension. You're looking at cosmic furnaces that dwarf everything we know, burning millions of times brighter than our sun, existing in a scale that our primate brains never evolved to fully grasp. And yet, even the largest stars are just tiny specks in the grand cosmic ocean, scattered across a universe so vast that light from some stars has been traveling for millions of years just to reach your eyes. The universe is big, really big, and we're only just beginning to understand how big. If you enjoyed this cosmic journey, make sure to like this video, subscribe to the channel, and let me know in the comments which space topic you'd like to explore next. Thanks for watching, and remember, you're amazing, but you're also really, really small.